Hello, everyone, and welcome to the joint webinar hosted by Pointing and Marcom. While we wait for all participants to join, we will share a brief video. In the meantime, please let us know where you are joining from. Feel free to type in the chat. And after the video, Luca will introduce the session, and we hope you enjoy the webinar.
We have been making wireless happen for as long as we can remember, and we always will. We are specialists who love our work, experts in our field. We take great pride in what we make and what it means to people. We hone our skills, refine our craft, and master the art of engineering. We are passionate about innovation and creating the best product that we can deliver. We forge, we learn, we build, and we grow beyond. It's more than just our vision and mission. It's our passion. We are Pointing, and we will take you beyond a connected life.
Luca, you can start your introduction.
Salve a tutti, oggi abbiamo organizzato questo webinar con Pointing per analizzare le loro soluzioni sul mercato IoT delle antenne. Pointing è un'azienda che ha una grande competenza e dei prodotti estremamente interessanti nell'ambito delle antenne. Noi collaboriamo con Pointing, Marcom collabora con Pointing già da parecchi anni. Io sono Luca Marani, responsabile tecnico di Marcom. Oggi abbiamo con noi Yuji Carvaglio, che è responsabile vendite per l'Europa di Pointing, che condurrà questo webinar e noi saremo qui a disposizione. Ci sarà tutto il webinar sarà improntato sulla modalità di scelta delle antenne IoT, non solo con informazioni relative al marchio Pointing, ma in generale anche sulla parte tecnica che entra nella scelta di un'antenna. Alla fine del webinar sarà un Q&A, una sessione di domande e risposte, Q&A, quindi saremo a disposizione per qualsiasi tipo di approfondimento tecnico, sia in inglese che in italiano, quindi se qualcuno parla solo italiano può tranquillamente esporre le sue domande. Inoltre ci sarà alla fine un interessante e utile regalo che Pointing ha deciso di mettere a disposizione, che vi faremo sapere alla fine di questo webinar. Lascio la parola a Yuji che condurrà il webinar e lo ringrazio.
Thank
Please.
you, Luca. I'm very happy with myself. I understood everything. Hi everyone. My name is Hugo, as Luca well said. I'm Portuguese, so I do understand if Italian speak just as articulate and slowly as Luca did. I understand some Italian, but I don't speak it, unfortunately. I'm not sure if they are on, but Beatrice, make sure that the subtitles will be on. So as I will speak in English, the subtitles will be there in English as well. But possibly easier to follow as well as I speak. As Luca said, feel free to place your questions either in English, either in Italian. We will address them by the end of the webinar. And you can input them as I speak. We will only address them by the end, just so we don't forget about them, you can input them as I speak. So welcome everyone. Thank you for being here. Shall we start already? We're 5 minutes past the hour. Luca, if you want us to wait a bit more, we have I don't know, 30% or not even 30% of the people who had registered already in. Possibly a few minutes more will allow still people incoming. So I'm happy to wait a few minutes more if you think that's worth it.
We can wait 1 minute. Okay, no problem.
Okay.
If you want, in the meantime, to introduce the pointing in general, so it's can be.
Okay. No, okay, let's give it 1 minute then, because I will introduce it. It's midway through my presentation. I will touch on who we are and what we do, so it's fine. I'll give it 1 more minute then. But in essence, as Luca was saying, we are effectively an antenna manufacturer. We've been manufacturing antennas for over 25 years. We started around 2000. And today we mostly do 4G, 5G antennas. In the past, we did a lot of Wi-Fi. We still have a number of Wi-Fi antennas. We have some LoRa antennas, but the reality is our specialties is definitely 4G, 5G. We have some Wi-Fi, we have some LoRa, we have some RFID. But as Luca was saying, a lot of the knowledge I will share today is around the fundamental of antennas, around the fundamentals of how to successfully install an antennas, the considerations, what you need to think about. So it has value not only from a 4G, 5G perspective, but also from any RF wireless conception that you may think of. So yeah, let's get on with it. So I would like to start by telling you Andrea Rossi's story. Andrea is not his real name, but everything else in this story is very much real. Andrea was responsible for the communication systems of a utility company in South Africa, where Pointing is from. And he was told that the company was about to deploy 1,000 smart meters across the country, which he would have to connect to their monitoring systems. Andrea inspected the technical sheet of the smart meter. He realized it came out of the box with a 4G module and a little antenna connected directly to it. He knew one of the areas where these smart meters would be deployed had really good 4G coverage, so he never really thought too much about that. He decided he would just configure the gateways, send them to the installation field technicians, and then it would be plug and play. The company went ahead and they installed 1,000 sites. After 1 or 2 weeks of having everything installed, it was obvious that something was not working well and some information was not there, and they started registering how many of these smart meters were not reporting the information in the time or as often as they needed it to be. They found out that more than 50% of the locations didn't work well, so they picked up a few of those. They added antennas to the smart meters, and after seeing a significant shift in performance, they decided they would need to act on all sites which were experiencing issues. They ran the math, and they realized it wouldn't be cheap, but there was no way the business could accept that things would stay the way they were, so they had to go ahead and do it anyway. So once all the smart meters were fitted with antennas, the connection was then possible at all periods of the day, and the problem was no longer there. After that rework was done, they went ahead and did the math. Okay, how much would it cost us if we had done it well to start with, if we had planned it properly with outdoor antennas properly installed to start with? They immediately realized that even though they would need to invest and deploy more antennas, the cost would still have come lower. Just in case you're wondering, the antenna is this antenna that you see here on your screen. So what lessons does Andrea's story teach us in this case? Lesson number 1, and I think the main takeaway for today, I hope that you take away from today's session: when thinking about wireless systems, regardless of the application, it is a good quality antenna installed correctly, and that's very important as well, that's going to ensure a stable, reliable, and consistent connection. Technically, this will translate to higher uptimes, higher throughputs, lower latencies, lower jitters. But in practice, it means for the business operation, fast access to the data, business running smoothly, lower total cost of ownership, and for you, a lot of you, IT professionals, system integrators, installers, more time deploying new projects and prospecting for new business, and less time troubleshooting solutions that you've sold already. The lesson number 2, And very important, street coverage, or shall I say smartphone coverage, is not the same as the coverage for an LTE device would experience when deployed inside of a street cabinet, a traffic light system, wireless connected system like a sensor, an alarm, a CCTV. Same thing for indoor when we are considering a building. The networks are designed to provide street coverage and not necessarily inside of stuff coverage. Lesson number 3. There's a Portuguese saying that will translate directly to English: you get what you pay for, right? So cheap turns out to be a bit more expensive by the end. So starting the project without adding the antenna seemed like an easy way of getting on with it and a cheap way of getting on with it, but it turned out to be more expensive. And that's even disregarding the cost of transport and tolls, the cost of overtime, the loss of productivity, and the cost of reputation to your company. So today I'll be trying to make sure that Andrea's story is not your story. But more importantly, I'll be hoping to effectively share how can antennas contribute for wireless systems to work at their best, why antennas are so relevant, and how can we choose between the different antennas that exist in the market. And who am I to do so? I'm a 36 years old telecommunications engineer. I worked at the beginning of my career for 6 years as a project manager and as a technical manager in wireless projects, just like many of you. So I was doing radio links, point-to-point, point-to-multipoint, licensed and unlicensed, Wi-Fi networks, LoRa networks, 4G, 5G for buses, for river cruises, you name it. So I started and I had a lot of hands-on experience. As time went by, I moved more to the business side of things, and today I am the head of sales and operations, as Luca said, for the European division at Pointing. Be it that I still have a lot of experience, I still get involved in the technical aspect of a lot of projects. So even though my role is no longer technical, I still get to hear and learn and participate in a lot of these discussions with our customers, and that's hopefully some of that experience that I bring to you today. What about Pointing? Who are we? Where do we come from? As I said, South African antenna manufacturer. We were born in 2001. We have been specializing in creating, developing, and manufacturing 4G, 5G antennas, as well as Wi-Fi and LoRa. In the beginning, military and defense and commercial antennas both existed under the same umbrella, Pointing Antennas. Today, those two companies part ways. One, the military and defense entity, is a publicly traded company. We are still a privately held company. Our focus is, it's a very defined and well-defined one and single one: stable, reliable, and consistent wireless connectivity, regardless of application, regardless of location. We have over 70 patents on antenna design and antenna design techniques, and we operate in 5 different markets. Today, as Luca mentioned, we will be focusing mostly on IoT. The considerations between IoT and fixed wireless access, they're more or less the same, but we manufacture antennas and design antennas for different verticals. Fixed wireless access being the one we are most well known for in Europe and in South Africa, for example, and that's internet connectivity for individuals, businesses, urban, rural locations, as permanent setups or as interim setups, as a main way to connect to the internet or as a backup to connect to the internet. Then we have, of course, transport and mobility, buses, motorhomes, caravans, emergency vehicles. If it moves, needs 4G, 5G, Wi-Fi, or GPS, we've got it. Maritime and coastal, we're very big in that market. We do a lot of the super yacht market in Italy as well with our antennas, but not only the leisure vessels, the super mega and even smaller yachts, but a lot of our success, and I would say the biggest part of our sales, go to the commercial shipment. So that's container vessels, cargo ships, offshore platforms, you name it, tugboats. And then finally, we have IoT and mining and tunneling, very specific portfolio that we have, with some of it being patented as well. Anyway, with this being said, and with these formalities out of the way, I'm hoping to effectively share today, as I said, how can antennas contribute for wireless systems to work at their best, why antennas are so relevant, and how can we choose and deploy these antennas. I'll be using this bus for this analogy, okay? And I hope that in the future you'll remember this analogy. Think about the bus. Comfort and safety of the passengers, it's somewhat one of the top priorities of the bus operator. Quite straightforward. If there are no passengers, there's no tickets being sold, there's no revenue, there's no business. Now, if you look at the tires of the bus, even though they're not the most expensive part of a bus, they are of crucial importance when driving it. Tires are what provides the bus with grip to the road. And on top of that, they're also partially responsible for more or less vibrations felt by the passengers. Now, if you have a €500,000 bus and you drive it with low quality tires, you'll not be able to get the most out of that €500,000 investment, right? Neither in terms of comfort and much less in terms of safety. A tight corner while overspeeding, or something gets in front of the bus and the braking system doesn't work as it should, there goes the bus, there goes the passengers, potentially there goes the business. Even though a premium, those €500,000 was paid for the bus itself, overlooking this fine detail, the tires, was a very dangerous decision for the business. Now, from the contrary, the bus company pays close attention to details when selecting the right tires for the bus. Passengers will be safe because there will be grip to the road and the journey will be smooth. With sufficient grip, all the braking technology within the €500,000 bus will be able to work smoothly. In that moment, the company can actually get the most out of their overall investment and all its fancy technology. Why is this relevant and how does this match our IoT world, right? For your typical connectivity scenario, picture the bus as being the router. Imagine the passengers on the bus as the data being transferred to or from the devices or people who are connecting through the router. Now the antennas are to a cellular router exactly what the tires are to a bus. If you choose the right antenna, you'll get as much grip to the signal as you can. With the right antenna installed properly, you'll be able to get the passengers to the right destinations. Business will flow, people will get access to whatever resources they need to get access to, and you'll be avoiding a lot of headaches like revisiting the sites like Andrea had to do in South Africa. If you choose the wrong antenna, you'll have no grip, and with no grip, not even the most expensive technology or most expensive routers will work. So now we know why we need a good antenna. However, we also need to understand why we need that antenna to be installed properly outdoors for almost all 4G and 5G applications. Imagine you are in a rural area, or imagine it's the winter time, and you're on the phone with someone, and then because it's the winter time and it's cold, you step inside, and the call quality drops, or the call just fails completely, all right? The reason why this happens is because there's, on average, and taking into account the types of buildings we have here in Europe, a 20 dB difference in signal between the signal outside and the signal inside of a building. And for street cabinets and traffic light systems and other IoT applications, it may not be 20 dB. It may be more if we're talking about metallic cabinets, or it may be a bit less if it's fiber, but with some metallic elements and electronics inside. And what do these 20 dB mean? So 20 dB is enough for getting you from an excellent signal level to a cell edge or a bad signal level. Or most importantly, on remote and more rural applications, it's what's going to be the difference between an average performance or no performance at all. So definitely the antenna needs to be good, but also needs to be installed properly. One other analogy, because I know we, the Southern Europeans and Italians with Ferrari in specific, are very much into F1, right? Formula One. Think about the picking the right antenna as having a Formula One car in your Formula One in your Formula One. Placing it correctly and choosing and installing it correctly is like bringing that F1 tire to the right temperature. Because you all know it may be the best tire, Pirelli, best tire in the world, but if it's not on the right temperature, you have no grip. So now I'm going to talk to you about good and bad antennas and how to differentiate through those. And I can assure you, if you just know these 10, 12 minutes of information I'm going to share with you, you'll already be way ahead of a lot of people installing and selling routers in the market. Unfortunately, most people evaluate antennas on two things, or shall I say three things. Frequency and technology. So I know I need a 4G, 5G, or a Wi-Fi or a LoRa antenna. That's frequency and technology. And then gain of the antenna. People traditionally think that the higher the gain of the antenna, the better the antenna. But that's not necessarily the case. And then the third thing, of course, like with everything in life, price. So the price to match the application and the criticality of what we are about to do. So there are many more aspects that need to be accounted for. You see on your screen 8 aspects on this slide. And on top of these 8 aspects, there's one that we're not seeing, which is keeping them, and probably one of the most important ones, keeping the balance across all the frequencies between gain, radiation pattern, and the willingness to accept power across all the frequencies of operation of the antenna. And this is not an easy task, and it's why our antennas are effectively differentiated and have a better performance. So what do all of these 8 aspects of antennas mean? Fortunately, I won't have the time to go through all of them. I will touch on just of the, I would say, the most important ones. Frequency, gain, radiation pattern, and diversity. All the other ones are important, but I think these are absolutely critical for you to understand when you're choosing an antenna. When people go shopping for an antenna, they look at the bold letters on top of the data sheet, right? So let's look into these. If I look at the bold letters of the data sheet I have in front of me, what do I know? I know the frequencies of operation, okay? 600 to 7,000 megahertz. I know the gain of the antenna, or I know that number, and I know that it's a directional antenna as well. But do I know how good the antenna is? Absolutely not. Let's start with the frequency. Frequency of an antenna is effectively the range of frequencies that an antenna was designed to operate at. Antennas don't care about technology, they only care about frequencies. So if someone says they need a 4G antenna in Italy, they're effectively saying that they need an antenna that has been designed to operate between 700 megahertz and 2700 megahertz. If they say they need a 5G antenna, we're then talking about 600 megahertz to 3800 megahertz on public 5G for the time being. Now, when it comes to gain, and especially that number on top of the data sheet, the manufacturers, like ourselves, everyone in the industry, they'll publish the max gain of that antenna across all frequencies, taking into account all directions. And this is one of the first challenges when uneducated people or customers are buying or shopping for antennas. People don't know that the gain, that one number is going to change throughout the frequency of the antenna and depending on the direction from the antenna, from which you're measuring the antenna. You can't, or you cannot effectively represent the gain of the antenna with a number only. So let's see what gain is, because I think this is effectively the main misconception that exists in the antenna world. Gain is the capacity of an antenna to focus its beam on a given direction for a given frequency. So if you were to come across the top of the data sheet of two antennas, the two antennas that I have represented here on my screen, you'd see that both were covering the same frequencies and with the same gain, or at least that same number. Both antennas would specify 8 dBi of gain, which would be true. That's the maximum gain across all the frequencies. But one would be almost 20% cheaper. So in principle, they cover the same frequencies, they have the same gain. There's really no difference for me to spend the extra 20 euros, right, or 20 pounds. When selecting wideband antennas, we should look for a stable gain across all the frequencies they operate at. You don't know which frequency band your router will be connecting to, as it depends on the network, especially when we're talking about 4G and 5G. So we need to look deeper into the gain plots, which is these two images that I'm showing you here on my screen, to know what you can account for. In this case, it would be definitely worth expending the 20 euros more or the 20 pounds more, because you see that one gives you a flat 8 dBi always peak gain, and the other one doesn't. By the way, the antenna on the left is a theoretical antenna. It doesn't exist in the market, such an antenna, especially for 100 euros or 100 pounds. So this is the consideration about gain. But now, what about that balance that I was telling you about between frequency, gain, and radiation pattern? The gain plot will give you the peak gain for each frequency, but it only takes into account the value where the gain is the max for that frequency for that antenna. we need to consider the performance of the antenna in all directions, as well as all the frequencies which are relevant for our application. In Omni antennas, for example, we want to see the same gain 360 degrees around the antenna, regardless of the frequency we are needing to use or considering. On directional antennas, we need the gain to be pointed from the center or towards the center of the antenna we are installing. I'm going to show you a video because I think this is super well explained. I don't need to reinvent the wheel. That shows you how this gain varies with radiation pattern varies with gain, and what's the importance of the radiation pattern when you are installing an antenna. Let me know if you can hear the sound.
Yes.
When we look at antenna radiation patterns, it is important to note that we are looking at two-dimensional renditions of what is happening in three-dimensional space. The horizontal plane, or azimuth plane, is a view of the pattern from the top, as if it were sliced down the middle. The vertical plane, or elevation plane, is a view of the pattern from the side, as if it were sliced down the middle. Antennas are often measured and advertised by how much gain they have. But this can be misleading, without considering the propagation of signal on the radiation patterns. Omnidirectional antennas and gain. Increasing the gain on an omnidirectional antenna increases the reach of the radiation pattern. From 0 to 3 to 6 to 9 dBi, we can extend the reach of our antenna as required. Badly designed antennas can show high gain, but in reality offer inconsistent coverage. A good antenna needs more than just high gain. It needs consistency. What seems to be a good antenna when viewing the vertical plane can be a very bad antenna when comparing it to the horizontal plane. This is an example of a poorly designed antenna with seemingly high gain. It covers less than a well-designed antenna with lower gain. In practice, a bad antenna will receive signal from one or two locations if intentionally aligned.
Oh man, how was that response? I love this slide, and I think this is the most important part of this, right? So here we're talking an omnidirectional antenna. So when you buy an omnidirectional antenna, you expect the performance to be the same 360 degrees, right? If you go down the route of just looking at the peak gain and the radiation pattern is not good, you see this antenna could pick up very far in a certain direction, but we're buying it as an omnidirectional. So we expect it to have the same performance 360 degrees. And if you guys are also doing point-to-point links and radio and point-to-point point links, you are very used to path loss and link budget calculations, right? And you know that if you do it in a way, but then if the antenna doesn't give you if you change the direction you are considering, very common on point to multi-point radio links, that you cannot consider the same gain because the antenna on a 90 degree from the center will have a different gain from a peak gain. And that's not expected on an omnidirectional antenna. You want it to be truly omnidirectional to cover as much ground or surface as possible.
Intentionally aligned that way, while a good antenna would receive signal from multiple locations, improving the reliability of the connection. Directional antennas and gain. To increase gain and focus a directional antenna's radiation pattern, we use reflectors to control how the waves propagate. In much the same way as with omnidirectional antennas, directional antennas can be constructed poorly and seem like they provide higher reach. This causes spotty reflection of the signal, and while reaching longer distances, provides very poor coverage. So now you know why Pointing puts so much design effort into our products. Our objective is to provide superior patterns performing consistently over the whole frequency band.
So as she was detailing very important radiation pattern. If this is not yet clear, I would encourage you, and I'll touch on it a little later. We have built an entire academy just about antennas, just because as we are trying to sell antennas, we understand there's such a lack of know-how on the radio frequency fundamentals. So If you're willing to learn more, devote a bit more time to this, be it on the antennas themselves, and also on the specific IoT, fixed wireless access, maritime mobility. We have the Pointing Academy, and you can ask Luca and his team to create you a login, or just let him know that you want to go through you get a certificate at the end. And we have 6 courses. One is the antenna fundamental, touches way deeper on these topics that I'm showing you here today. Then we have 1 course per each of the verticals that I showed you, the markets that we address, because of course we want to ensure that our customers have that knowledge. Okay, I want to touch on the last aspect that I mentioned, right? So we discussed frequency gain, radiation pattern. And now, as you guys know, in 4G, 5G, it's all about MIMO, right? And what is MIMO? Basically, MIMO is a usage of antenna diversity. And antenna diversity is a set of techniques where 2 or more antennas are used to improve the quality and reliability of a wireless links. There are 2 common ways of achieving antenna diversity. First of them, spatial diversity. So basically, you take 2 antennas that look alike, or they're the same antenna elements, and you space them apart. How does this work? What phenomenon is spatial diversity fading? What is fading? Imagine you're driving your car, listening to a FM radio, and you stop on a red light, and the music stops. And then you move the car a bit forward or a bit backwards, and then the music resumes. What happened? The sum of all the radio waves that was getting to your initial position of the antenna was 0. So there was no sound. But if you move the car a bit further or a bit backwards, then you pick up signal again, because then the sum of all reflected radio waves is already a positive amount. So effectively, if you had this FM radio antenna on the front of your car and another one on the back, you would never have fading on FM radio, or at least in these circumstances. Same thing goes for 4G, 5G. The second technique of diversity is polarization diversity. When the base stations send the radio waves on 4G and onwards, they don't send just a linearly polarized, vertically polarized radio wave. They send vertical, they send horizontal, and they send -45 and +45. If you are receiving, if the radio wave gets to you vertically polarized, and your receiving antenna is vertically polarized, you get 100% match. It works. You get all the signal, right? There is available. But if the radio wave gets to you horizontally polarized and you have a vertically polarized antenna, then you lose 34 dB of signal. And you saw that 34 is a big number. How do you fight this? On the same location, you have a vertical polarized antenna and an horizontally polarized antenna. To understand polarization diversity, think about polarized sunglasses and looking at your mobile phone. So if you are wearing polarized sunglasses and you rotate your phone, the image is there, but you don't see it. So those are techniques to improve the quality of the radio link. This fundamental knowledge will help you make better decisions, but remember, everything holds up on paper. So when you're looking at a data sheet, the answer is in looking for real measurement-based data sheets. Radiation patterns, horizontal and vertical radiation patterns and beam widths varying across all the frequencies. Antenna performance plots, VSWR and gain plots throughout all the operating frequencies. And then everything else, right? So mechanical specs of the coaxial cable, the specifications of the build quality of the antenna, environmental specifications, mounting options that come with the antenna. So how should it look like? So when you look at the radiation gain plot and the VSWR plot, it should look like this. There's some variation across the frequencies. It's not a flat line, but there shouldn't be massive dips on the frequencies which are relevant. And finally, from a technical sheet perspective on commercial antennas that are wideband, how does radiation patterns should look like? Something like this. As you see, they're not perfect. They're far from being perfect. And if you're doing radio links point to point, you are used to very low VSWRs and very well controlled radiation patterns. But on wideband antennas like 4G and 5G, it's harder to control them within a commercially relevant price point. So as you see, they're not perfect. This is ours. We publish them exactly as we measure them. Not perfect, but pretty close to what a good directional radiation pattern should look like. So again, I had no time to cover everything. Do get in touch with us to get you a position on the academy. You'll be able to learn more about it then. So now let's go on to more practical examples on how to make what do we need to know to make the right decisions for IoT and fixed wireless access antennas. First of all, first advice: how do the operators design their networks? They use lower frequencies on rural and remote areas because they propagate further, and higher frequencies on the urban and suburban areas. This is because the cells, the base stations, they have a limited capacity. So if you use higher frequencies, you make those cells smaller. So you find your capacity in a smaller space. So in a city, you can get 10,000 people in a very small space, but to get 10,000 devices on a rural space, you need to cover a lot of ground, and that's why you should use the lower frequencies. In any case, all the technologies, 4G, 5G, and whatnot, they exist in all these different frequencies, right? So the operator operates them in all the different frequencies. Just be mindful when you're choosing an antenna. Even though you may think it's a rural application, you cannot choose a single band antenna, just an antenna that operates on the lower frequencies, because the operator can change the frequencies and you will not be asked if you're okay with it. They will just change them. So you still need, when you're choosing an antenna for a rural application, for example, you can look with a bit more attention to the performance on the lower frequencies, but you still need an antenna that covers all the frequencies. Then attenuator factors, second practical advice. Different things out in the field, in the environments where we install our antennas, will have different impacts. Some of them have a higher impact, others have a lower impact, but even the open air has an impact. So just be mindful of those. Near and far obstructions. The closer you are to an obstruction, the higher the impact is. Think about the flashlight, right? I have a flashlight here and I have it on. If I was to measure the amount of light that's immediately behind my hand here, there would be no light, right? It's pure shadow zone. But if I was to measure it further down, there would be some light that's going over my hand, below my hand, and being reflected out of my wall. So obstructions which are further away from your antennas have a smaller impact. In terms of materials, of course, metal has a big impact, and of course, rainfall and free space, they have a lower impact. Third advice, and we always get the question: so how long can I make my cable, right? My coaxial cable, how long should it be? Depending on the criticality of your scenario, you should not waste more than 3 to 5 dB on the cable. How long is this? Depends on the quality, on the cable you're using, the type of cable. So if you're using an LMR 200, for example, to get 5 dB loss, you can use 10 meters. And if you're using LMR 400, you can almost use 20 meters. And how do we measure this? We measured it on the 1800 megahertz. Because it's wideband antennas, we don't know what frequency is going to be used. But if we measure it on 1800 megahertz, 1000 to 800 megahertz, if the frequency is lower, the coaxial cable loss is also lower. If the frequency is higher, it's higher, but you are in a more dense area and probably there's more signal there. Fourth advice, 2 types of antennas, when to use which, and what's the advantage and disadvantage of using directional or omnidirectional antennas. Omnidirectional antennas. You see if it's a good omnidirectional antennas, you see all the masts around you, so that your device or your router can connect to the different masts. If one goes down, it will pick a different one. Very easy to install, but they have a lower gain and they pick interference 360 degrees around them as well. Directional antennas, they only listen towards the direction, so the interference around it's blocked. They can ensure you, as they are isolating the noise and they have a higher gain, you will have a higher signal to noise ratio. So your throughput and latencies will be better. But you are dependent on the cell tower you are pointing your antenna towards. And finally, fifth advice: if you know the radiation pattern, then you are better capable of making decisions on where to install this antenna. For example, this antenna is an omnidirectional antenna, and it's all like this. So it can only listen and speak to these directions. So anything coming from this side, the antenna will not be able to listen to. Here you see it well installed on an EV charger, right? So you can listen to and talk to 360 degrees. Other requirements that IoT and fixed wireless access applications have to do with form factors, environmental specifications, the types of environments you see in these pictures, right? For example, installation accessories. You may need an antenna that has multiple installation accessories out of the box because you don't know where and how your installation teams are going to install the product in the field. So an antenna that comes out of the box with multiple installation accessories may be relevant for your particular use case. So all these use cases, you can read about them on our website. I'm already 5 minutes past my time, but all in all, my last advice to you is very simple. Just don't be like Andrea, right? So get trained and knowledgeable about antennas, use it to differentiate yourself and your company from your competitors, shift the conversation from the router, which is very crowded. Everyone talks about the routers. Everyone just thinks about the routers. Talk about antennas and radio frequency knowledge, because that will differentiate you. Think about the bus tires and the grip to the signal. Have that example in your head if you need to explain what the importance of the antenna is. Look past the bold letters. The gain is not just that number. There's way more to it, and you need to consider radiation patterns as well. Remember, different applications, maybe omnidirectional or maybe directional antennas. You need to know the benefits and the disadvantages of both. Don't assume street coverage is the coverage you're going to get in your project. And all in all, spend more time deploying new projects and not troubleshooting old ones. So this is it from me. As you saw, I barely touched on products, and we didn't touch on products on different specifications and different products and MIMO 2x2, 4x4 directional and indirectional and omnidirectional. But as you can imagine, we have products to fit all these use cases. And I would like now, Luca, I will ask Luca now if he may show you. Your best option always is pick up the phone, call Marcom and ask them what antenna would you advise. That's, of course, they have a lot of experience and they have a lot of know-how. The second best, you can do it online on their platform, and Luca will now show you how.
Ok, grazie Ugo. Molto chiaro, molto preciso, molto interessante. Penso che Ugo abbia toccato i punti chiave con cui abbiamo a che fare ogni giorno quando riceviamo richieste dai clienti sulle antenne. Per capirci, giusto per condividere alcune altre cose rispetto alla presentazione di Ugo, volevo condividere una cosa che spiega un attimo di cui stiamo parlando. Ad esempio riguardo alle antenne che dicono qualcosa che non esiste. Tutti i giorni riceviamo richieste di questo tipo: voglio anch'io un'antenna a 35 dBi, antenne che praticamente sono un sogno, nel senso che sono chiaramente delle FAC. Basta andare a leggere, ad esempio, in questa antenna di Amazon i feedback per capire di cosa stiamo parlando. Quindi spesso e volentieri ci dobbiamo scontrare anche noi con clienti che purtroppo non hanno la competenza per poter capire che certe cose non esistono e che bisogna affidarsi, diciamo, a dei venditori professionali per avere delle soluzioni per i loro problemi. Lasciando stare questa antenna, diciamo, di cui ho comunque voluto farvi vedere un'idea per capire cosa succede, Ugo ha parlato della Point Academy. Questa è la Point Academy. Se voi cercate su Google Point Academy. Ci sono tutti i corsi che sono resi a disposizione, sono corsi online, sono molto interessanti e riescono anche a dare delle nozioni estremamente importanti nella scelta delle antenne. Ci sono corsi, diciamo, base e corsi avanzati per le diverse categorie verticali, come ha detto Ugo, oltre a 4G, 5G, quindi antenne cellulari, antenne Wi-Fi, antenne IoT. Pointing è specializzata in alcuni settori che possono essere ad esempio quello del marittimo, in cui le esigenze sono anche un po' particolari per via dei materiali utilizzati e anche per, diciamo, la modalità di propagazione in ambito, diciamo, marino del segnale e un fiore all'occhiello sicuramente di Pointing, le soluzioni per il mining, quindi per le miniere o per i tunnel, dove è necessario utilizzare antenne che hanno, diciamo, delle propagazioni particolari per poter arrivare a grandi distanze, e in questo ambito diciamo che Pointing è sicuramente un riferimento sul mercato per questo tipo di antenne. Volevo poi farvi condividere un nuovo tool che andremo a mettere fra un po' sullo shop. C'è uno strumento ideato da Pointing per andare a identificare l'antenna necessaria per la propria applicazione. Quindi avremo un tool di selezione, l'abbiamo chiamato Scegli antenna, in cui scegliendo ad esempio il tipo di applicazione, tipo building, il tipo di i sottoelementi che possono caratterizzare l'antenna, posso andare a selezionare il tipo di antenna e mi verrà proposto le antenne o gli elementi di cui ho bisogno. Come ha detto all'inizio Beatrix, abbiamo ideato un discount, un certificato di discount, che è questo che vi faccio vedere, IoT 10, permetterà di avere sul nostro shop, automaticamente inserendolo, uno sconto del 10% ed è valido fino alla fine di febbraio 2026, chiaramente su un solo ordine. Quindi se volete usufruirne, lo rendiamo disponibile. Adesso direi che possiamo eventualmente aprire la Q&A section. Se qualcuno ha delle domande o risposte in particolare, se ha bisogno di qualcosa, siamo a disposizione, e eventualmente poi comunque ve lo chiarisce anche Beatrice, tutto il webinar sarà reso disponibile a chi ha partecipato e potrà essere, diciamo, visto anche o condiviso con i colleghi successivamente. Intanto vi ringrazio e rimaniamo a disposizione se ci sono delle domande.
Thank you. Luca, maybe you can share the Choose Antenna link on the chat to everyone see and test by themselves. If you have any question, you can type in the chat or you can type in the Q&A that we have here below. So please feel free to type your questions. We will try to answer them all, but if we don't have time to answer all, we will send a private message and then we will answer them.
We have no questions. The presentation was very, very clear.
Yeah, it was very good, Hugo. Maybe you can type in Italian if you feel more comfortable, and Luca will translate them or answer in Italian. Okay, no. Oh, yeah, we have a question from Federico. Luca, maybe you can read.
Sì, ok, la domanda specifica è se il tipo di antenna può variare in base alla categoria del modem, categoria 4, categoria 6. Yuji, if you want, you can answer, or I can answer, no problem.
It's well, if you want to answer it in
No, no, it's no
Italian
problem.
or translate it. So basically, the antenna doesn't really take into account the Cat3. It just takes into account if you are 2x2, 4x4 size of antenna. So depending on the number of antenna ports that you have on your router, that's how you choose the antenna. End of the day, it's very important. I don't think I touched on it, but when I talked about diversity. If your router has 2 ports, you should use the 2 ports, because you may think from on older, so Cat 4, if I'm not mistaken, only transmits on one channel on one port, but receives on the two ports. Later, or more advanced categories on LTE, and I'm speaking under correction because I don't know the specs on the LTE so well. For example, if you're talking about the 5G router, 4 connectors, then that one will transmit at least in 2 ports and receive on 4 ports. But so effectively, to ensure that you have more resilience on the radio link, you need to connect all ports. Now, when it comes to the technology and the active part of being Cat 4 or Cat 6, doesn't make a difference to the antenna. The antenna needs to cover the bands that radio works for, and then have the same number of ports that the radio has.
Volevo aggiungere alcune cose che magari possono essere interessanti che riguardano la tecnologia cellulare, quindi collegamenti 4G, 5G. Allora, un paio di cose. Prima cosa che può essere interessante è se il dispositivo è fisso o se il dispositivo è su un mezzo mobile. Quindi l'antenna può variare abbastanza, nel senso che se il router si trova su un mezzo mobile, sostanzialmente è molto importante il pattern di cui parlava Yuji, perché il pattern permette chiaramente l'uniformità di pattern permette di raggiungere più BTS contemporaneamente. Come sapete, il router cellulare si collega al carrier tramite le BTS, quindi tramite le antenne dell'operatore. Se abbiamo un pattern molto regolare e sull'omnidirezionale abbastanza esteso, riusciamo ad avere copertura di più BTS mentre il mezzo si sta muovendo e quindi riusciamo ad esempio a avere una continuità di comunicazione sia passando da una BTS all'altra mentre il mezzo si sta muovendo. Per quanto riguarda invece i router cellulari fissi, quindi una posizione fissa, l'importante è la distanza dalla BTS e quante BTS riesce a coprire. Spesso ci chiedono i clienti di avere delle antenne ad alto guadagno per poter, diciamo, raggiungere la BTS e avere un migliore performance. Però noi diciamo sempre attenzione perché l'antenna ad alto guadagno spesso e volentieri si accoppia a antenna direzionale. Antenna direzionale significa spesso collegarsi a una sola BTS. Questo talvolta può essere un problema perché se l'operatore mette in off la BTS per qualche motivo, perdiamo completamente il segnale. Quindi ci sono delle valutazioni da fare più generali che riguardano, diciamo, sia il tipo di posizionamento del router, dove sono le BTS, che tipo di distanza ho dalla BTS, perché come ben sapete, se il router cellulare è vicino alla BTS usa delle frequenze abbastanza elevate di comunicazione, se no va su bande a frequenze più basse, quindi bisogna andare a lavorare su un'antenna che ha delle caratteristiche anche in quel caso. Quindi diciamo, la scelta dell'antenna purtroppo non è dammi un parametro, ti do l'antenna, è una valutazione generale che riguarda più aspetti che vanno messi insieme.
If I may, look, I'm going to take over your screen because I just want to show
No, no
what
problem.
what you were describing in the beginning is this. Luca was talking about mobility antennas and now they are installed on top of vehicles. And if they don't have a truly omnidirectional diagram, this is what you're going to see. The bus is moving, and sometimes the connection is better, sometimes the connection is worse because it's not consistent, the radiation pattern of the antenna. But if the radiation pattern is good, you pass from one mast to the other, to the other, to the other, and the performance, that handover between masts always happens. I think this video translates exactly what you were saying, so it's makes it more visual.
Ok.
We have a question about when the webinar will be available. We will try to send them this week, but probably count with this week or beginning of the next week, okay? We will send the recording and we will send again the discount code just to remind you to use and to take advantage of this opportunity, because it's not every day that we have a special discount for attending a webinar, so it's really good. If you have any more question, please just type in the chat. If you don't,
Yes, scusa, Beatrice, ce n'è un'altra. Se ho un router di tipo teltonica su una posizione fissa, come posso misurare il segnale se è buono oppure no? E questo si può fare direttamente nel caso del router teltonica, come anche altri router, dal setup del router. Esiste all'interno un menu in cui si può andare a vedere tutta una serie di parametri, RSSI, eccetera, eccetera, che dà la qualità del segnale. Sull'Academy nel corso base c'è una slide specifica in cui usa proprio un Teltonica per far vedere come si può analizzare la qualità del segnale utilizzando quel menu del router. Quindi vi invito a iscrivervi all'Academy, al corso base dell'Academy, dove spiega esattamente questo tipo di problematica e fa vedere come si può dal router evidenziare la qualità del segnale che abbiamo tramite chiaramente antenna, cavo e router collegati. Ok?
Lovely. Okay, so
Okay.
if there are no more questions,
Well, so thank you all for joining us today. We hope you found this session helpful. We will send the recording to your email in the next couple of days. If you have any question that tomorrow you wake up and say, okay, I have a question, don't hesitate to contact us. You can contact always Luca, and if Luca has any doubt, he will contact Hugo. Don't forget to use your special discount at Marcom website. And on behalf of Pointing Antennas and Marcom, thank you once again for your time and engagement. And we wish you a great day.
Grazie a tutti, anche da parte nostra, grazie a Ilaria per aiutarci a organizzare il webinar, a Ugo e a Beatrice.
Oh, we
Grazie.
have
pleasure.
one more question. Maybe if you'd like to answer real quick.
C'è un problema
Matteo.
inverso, il router continua a staccarsi dalla rete perché trova tante celle, c'è un'antenna particolare che si può usare. Ehm, il router continua a staccarsi perché ha tante celle. Normalmente questo problema è un problema che ci crea, avere tante celle non crea problemi normalmente, ci crea problemi ad esempio sui router posizionati sui confini. Ad esempio abbiamo parecchi problemi in zona Trieste, ad esempio, in cui il router stacca e attacca perché passa dalla BTS italiana alla BTS slovena. In quel caso è possibile selezionare l'operatore e quindi evitare che faccia il routing dall'altra parte. Normalmente più BTS non creano questo tipo di problema. Mi viene l'idea che forse è un problema di un'antenna che, come diceva prima Yuji, non ha un pattern adeguato e quindi si trova a perdere e a prendere il segnale perché è comunque al limite del segnale su ognuno delle BTS su cui è, cioè non c'è uniformità e quindi una volta è buono, una volta è cattivo e quindi salta da una all'altra. L'idea che mi viene è questo, ma bisognerebbe analizzarla nel dettaglio. Ok, era confine Svizzera come volevasi dimostrare. Ok,
Thank you.
Okay, lovely. Thank you, everyone. Thank you, Luca.
thank
Thank
you,
you, Ilari.
grazie a
Thank you,
tutti.
everyone who
Salve,
joined us.
Bye.
Bye bye.
salve,
Thank you. Bye
salve.
bye.